Good morning, good afternoon, good evening to all the attendees today. Welcome to Hackerearth Webinars. My name is Sunila Gollapudi, and today I'll be talking to you about one of the most interesting topics in machine learning. It is productionizing machine learning. I'm assuming today's crowd is a combination of beginners and intermediate people in machine learning. So what I'm going to do is spend some time in some basics, give you an overview, give everybody a bigger picture, and take you through the details of what it takes for us to productionize machine learning. Very nice to have you all, and here we start. So today, productionizing machine learning is what it's going to be, and we're typically going to talk about how do we architect machine learning solutions and operationalize them to scale. So basically, I come with a background of enterprise architecture, and I worked on machine learning projects and multiple technology-related projects in the past, and I'll give you a different, an interesting angle to machine learning. If you're expecting anything related to machine learning algorithms, how an algorithm works in detail in this webinar, you'll be disappointed, because I'm going to give you an overview and then take you through all the practical issues that a machine learning project faces and how do we handle them. So very quickly, the protocol for today. I'm going to be talking about this productionizing machine learning topic, and it's a 1-hour session. The first 45 minutes, I'm going to cover the complete session and go through the story I have to narrate to you all guys. And the last 15 minutes, we will choose to discuss the questions that the group has. So I'm personally open to even extend beyond the hour for any valuable questions we have. So welcome again. So before we start, I hope you all can see the screen out here. So before we start, a very quick introduction about me. So my name is Sunila Gollapudi. I work as Vice President Technology with Broadridge. I head the India Architecture Group for them. I'm also an author for Green Plum for Big Data Analytics and Practical Machine Learning, the first edition. It's in the market since January this year. And I'm right now working on the second edition for the same. So I've covered pretty much all the learning algorithms in the book and the code using Python, Julia, R, Mahout, and Spark in the book. And I drive all the enterprise architecture initiatives for Broadridge. Other than that, I have published a couple of IEEE papers on the same subjects, which I will cover with you. And at the bottom, I've given my LinkedIn email ID and GitHub details for you to, access and go through. So that's a quick brief about me. So I've got about 14 plus years experience in the market, and I started my career as a Java developer and moved to data architectures and machine learning after that. That's what it is. Let's quickly jump to our agenda today, right? I've got some interesting agenda items for you all guys. What I'm going to do is I'll do a very quick recap of what machine learning is all about, what are different learning methods, some use cases, a brief on some algorithms and what's it all about. Since it's just 1-hour session and you all know that machine learning is a very deep subject, I'm going to try and cover the bigger mind map of what machine learning covers. Then immediately I'll jump into what are the key challenges today we face in productionizing machine learning. So I would be using the terms execution, operationalization, productionization of machine learning, all in the same vein. So I'm going to focus on what top problems we face on the ground what we assume we are looking at solving versus what we end up facing on the ground. And for each of these challenges, I'm going to link back to some modern new era machine learning technology stacks. I will cover how machine learning is looked at when it comes to solutioning, in the sense the key reference architecture, different architecture styles that we have. So I'm going to cover Lambda architectures, semantic architectures, then metadata-driven architectures, and distributed data architecture, which includes massive parallel processing architectures. Then I'll also talk about LTP systems on how they work. Very quickly, I'll touch upon them and how these are helping us to solve. So that's what it is. And then the time for Q&A, your favorite Q&A, and I'll be open for that. And please be rest assured, even if I cross 45 minutes of time, I promise you I'm going to give you the required time to all the key questions and queries you have. So I'm assuming the crowd to have mixed knowledge, and what I understand in terms of statistics is we have practitioners and students as a combination in the crowd. So I'm going to try to keep it to theory concepts, give you practical examples, and then we jump into challenges. So here we start. So I start with my favorite mind map, right? I'm going to very quickly give you an overview of what machine learning is, the core semantics of machine learning, what it includes. So the key elements are, typically the concept of learning, multiple models, the data is key to it, what algorithms we have. Typically insights are the main ones. Then I'm going to cover with some core concepts with you and give you a life cycle of how typically machine learning works. So before I started really implementing machine learning applications and understanding the real world examples, and while I was trying to cover a lot of domain use cases in one of my previous publications, I have gone through quite a lot of courses, and I probably, the first 15 minutes I'm going to spend with you is going to be some theory. I'm going to be your professor in the class, and I'm going to give you the blackboard, whiteboard, whatever you want to call it, before jumping into the practical on the ground things. So I'm also going to give you a very quick comparison of what machine learning is and how is it different from a data science or artificial intelligence or mining or computational intelligence or statistical learning. Okay. So I'll also talk about some of the subfields. So let's quickly jump into this. So if you look at it, there are a lot of on the you look for the definitions in the market on the web. There are quite a lot of things. So primarily, what we're talking about here is the core concept of learning. So when we're looking at building new intelligent systems, the key becomes, or the mandate becomes, that we need to build the ability to learn, right? So typically, all the machine learning applications or projects are very much inspired by human behavior. So the way we are brought up, the way we learn and we put our learnings back into application, and then we use the same learning. So if you look at all these top technical definitions in the market, what I would simply say is machine learning is typically pattern search and building intelligence into a machine, right? So the focus is machine here, or system here, and this machine learns from its own experience and enhances its behavior for us, right? So let's take an example. Okay, we're talking about all the applications of programming we do as humans, and we write a function which takes inputs and which gives outputs. And typically, let's assume an input changes, I end up changing my code. So we have been doing all our system building since past on something called human writing the code, right? Now the trend has changed with machine learning, right? And we're talking about humans supplying data. So depending on the data, the machine will understand and change its behavior, right? So this is what it's all about. The idea is to take a set of data, build a learning model, and apply it to predict something else on the other data, right? Now, very importantly, one of the important things that you see with machine learning is data, right? Data is very, very important for us, and that is the cause for either the success or the failure of any machine learning project, right? There are two kinds of data. Very quickly, I'll give you the conceptual input because I'm going to cover the architectures which talk about these in the second part of the session, right? So there are two kinds of data. One is labeled and unlabeled data. Typically, your unlabeled data is something like a raw data. You've got a photograph, let's say a photograph of a famous movie star or a location or something. You really don't know what to do with that. So it does not really have a meaning to it. We don't know what to do with it. There's no meaning attached. So we call it unlabeled data. But the labeled data is something where we know the meaning. Let's say I have a customer and the customer demographics is there, and we say a particular customer called Sunila is from India and Hyderabad. So I know the location is labeled, I know what role it plays in the business context. So if I'm talking about, predicting my buying power of a specific product, then my demographics becomes important, and the meaning of my location becomes important, right? So this is very important for all of you to know. I'm sorry if I'm repeating this, but this is to lay the foundation to go to the next slides, right? So the labeled data, unlabeled data, and typically all the machine learning algorithms work on the combination of these two. That's when it produces a valuable meaning. I'll give you some real-world examples on this in a bit. And by the way, machine learning can also be used to label the unlabeled data. So I'm going to give you some examples of what that means too, right? Very quickly jumping into the second part of the data, right? So we've got, when we talk about data sets and that being a primary input to the entire machine learning project or, building the application, which is a machine learning application, we typically take the first set of data, right? So this data set, we know it's got an input, it knows what an expected output is, and then we model around it and we do it. Then what we do is we take the second set of data, and from the first set, whatever model we derived, we apply on the second set and just give the input data and say, what do you think would be the output, right? This is the two sets of data, and typically we call them as training data set and test data set. So if I've got, let's say 100 rows of data, I might take 60 rows of data to do training, and then I would test that model which I build on the rest of it. The percentage again is at discretion to the data scientists and the data analysts who are looking at data, right? So the key considerations are when we're building it, just quickly note about few of the terminology I'm using: overfitting of the data, underfitting of the data, the instability of the data, and unpredictable formats that come in, right? So this is going to be a very, very important part of our discussion 20 minutes from now, right? So I'll just give you a quick overview of what overfitting of data would mean. So I've got, let's say, 50 rows of data with me, and I'm trying to build a model around, or trying to build intelligence around the data I have. If I take 50 as too crucial for us and start building my model to be 100% accurate to the 50 rows, and let's assume my test data, which is 30 more rows, which is outside 50, starts failing, right? So I'm trying to build a model which is too accurate for my first data set, and I don't care about second data set. So this is a typical machine learning problem or data mining problem we speak about. So I'll cover most of it, but just register this. Data is important. So what kind of models we have? I'm going to cover this in a bit. There are three kinds of models: the logical models, the geometric models, and probabilistic models. Logical models typically use algorithmic approach. So I love deriving the business rules from it, right? And the business rules are like, if, let's say, somebody like Ayush, I can see the name, Ayush Arora belongs to Bangalore, and he's 30 years old, and then blah, 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 he would do something. I build a rule, something like that. The geometric models, again, use geometric algorithms or geometric formulae. So we typically use this to compare two models. Let's assume I have a data and I build a machine learning algorithm and I derive a model. What I use typically is to compare two models for this and say which model is more accurate. So measures of errors, measures of accuracy, or whatever would be using geometric models for us. The last model type is a probabilistic model, and these use statistical models to do it. So examples are like we've got Bayesian algorithms, we've got many more support vector machines. Most of them they fall under probabilistic models for us. So I'm going to do a little deep dive with my mind map in a bit, but just keep these in your mind in terms of what these categories are. So now the most important thing, so you all must have heard, everybody who must have Googled, read some videos, you all know what are different learning subfields. This slide is purely to confuse you with so many names. But what you all have to register is just simple supervised and unsupervised learning, right? So when I'm talking about building a system, I call building a system as supervised learning when I know what I'm solving for. I know the business problem and what I'm expecting to solve. I'm aware of it. That's when I call it as supervised learning. So I guide it to an expected output, right? And most of your label data will be used in supervised learning, right? Unsupervised learning is, I've got a bunch of data. I really don't know what I want to do with this. I take the data, I try to understand, do slicing and dicing, I assess the data, and I look at, and based on the data I have, I try to solve a domain problem. So these two are at a high level. Unsupervised learning typically uses a lot of unlabeled data. Let me tell you one thing, in any of the projects I worked on, the real world use cases across all the domains that I've worked on, I have never come across a supervised learning problem on the ground, right? So in my opinion, this is textbook, an absolute textbook concept. I love to believe that I am doing supervised learning, but on the ground, I start with a business problem. I'll talk about the challenges on this. I think I know what I'm solving, but the moment I look at data, I'm like, maybe not. I don't know this. I start looking at the patterns, and I don't think I really know. So, for example, supervised learning, decision trees is one. Unsupervised learning, clustering is an example. So, reinforcement, semi-supervised, deep learning, I'll not be covering in this session, right? But in case you have any questions on this, I can do a quick Q&A on these. I'm going to park these because they're a little deeper in terms of subjects. Very importantly, what are the different problem types? So we have classification problems, clustering problems, regression problems, optimization problems, simulation problems. So any business problem you solve, we can categorize in these sections or groups under the machine learning, right? Classification is typically, I give you an example. So Sunila is logged into my Amazon website, and would she be buying, jewelry, or would she be buying books? Typically, would she buy? What's the probability of she buying a specific product on that? It's typically a classification problem. I derive a business rule. So algorithms like association rules, decision trees, random forests, all of them would be, handling this. So I'll jump into the next slide. This is my favorite slide. By the way, guys, it's not my slide. I picked it up from one of the Microsoft guys who's built it, but I really love this slide. So what are we really looking at solving, right? What are we really looking at doing with machine learning? So I could predict values, right? So today, I started a new business to sell spectacles, and I started my sales, and do you think my sales in a specific region would go up, would go down, right? Some kind of a prediction. So if the problem is complex, my forecasting also would become complex. So I want to do, the data is not one-time data, it's continuously flowing in, so I do regression on the different data sets that's coming in. So that's one category of, problem solving I would do. So standard stock value predictions, standard buying patterns, or standard behavioral predictions comes under this, right? The second part is, very interestingly, finding out unusual occurrences, right? So we call this as typically the noise in the data, right? So one of the biggest business cases we have is credit card for the detections. For example, I know this one guy who's been using credit card has always been operating from a specific country, but suddenly I see multiple spikes from different country for larger amounts in different currencies. So what kind of anomaly am I detecting out there, right? So there are many interesting patterns that we look at, right? So this is one of the things. And the other one is clustering. So this is where important unsupervised learning comes in, right? So I've got data, but I really don't know what to do with the data. So I'm not understanding the pattern in the data. So I apply unsupervised learning techniques like clustering or many more methods to identify the patterns in data and then cluster it. And finally, the classification. This is a very straightforward decision tree kind of a problem that we're looking at solving. So this is a very deep subject. I'm not going to go too deep in this, but just giving you an overview of what this is all about. So before I really go into this slide, I'm going to give you a very quick overview of these categories. So I'm going to open this mind map, right? So all of you can see this, right? So typically, if you look at machine learning methods, you've got supervised, unsupervised. So the information goes very deep. So we're talking about decision tree-based learning. So there are many learning techniques, right? I'm going to cover one important learning technique before I go here. So here, this is a mind map of different learning models that we have. So decision tree-based learning, association tree-based learning, ensemble-based learning, clustering, regression, Bayesian kernel, instance, dimension, production-based learning. All these are different learning, methods we have, and then many more algorithms which are grouped. Some of them are supervised, some of them are unsupervised. Some of them use statistical methods, some of them use geometric methods, some of them use algorithmic mathematical formulas to do, right? And what I've done in this mind map is for each of these learning algorithms. So this is one thing which I really didn't find anywhere. I thought if I had to map it back, backtrace or backtrack to what algorithms I have and what are these algorithms categorized under and what kind of learning do they support, right? So for example, random forest or cart algorithms are typically decision tree-based learning. They come under supervised learning, right? So, and if you look at an example of support vector machines, they're kernel-based learning and they're unsupervised learning, right? Nearest neighbor, they're instance-based learning, they're unsupervised learning, right? So if you look at it, this is one short view I try to create myself, which is like a huge spread of algorithms we have today and what we map and what kind of problems we solve, right? So when I started learning machine learning, this is the first focus item I had, and getting back to my slide. So that's a very quick view on that. So if you look at it, I spoke a lot about what machine learning is, what are different types of learning methods, and I'm going to share some material with you, over the slides in a bit on some business cases that we solved too across multiple domains. But when we talk about this data science being a bigger problem, so what do we typically do? So we say, okay, I want to understand the business problem. I want to understand what data comes to me and how does it come to me and how can I integrate. How do I, arbitrate it or clean it? Then how do I model it? How do I get the insights, publish it, and get it flow back into the system? And how do I measure the effectiveness of it? So I've got some visualizations I show to my clients, and they speak about, okay, this is not what I'm looking at, there's something else I'm looking at. So we get feedback back and forth, and how do we incorporate these back. So by the way, this is what I've learned technically when I was getting trained a couple of years back on machine learning. But when I really started working on the core domain problems and use cases, I have seen a lot of different issues, right? So I have seen a lot of challenges on the ground which are not very visible. So whatever you heard until now, so if you look at this flow, if you think this is what data science is about or this is what machine learning is about, you will understand that there's only a percentage of the entire flow, right? So I would be very critical about this, and I might potentially give the entire flow just a 15-20% of the entire effort. So my capability of knowing what algorithm I should apply there, how a specific algorithm works, for which domain problem, what do I apply, and how do I demonstrate the output, learning R, learning Python. I thought that was all, but on the ground, that solves or that forms just 15 or 20% of the entire gamut of the problem solving. So it's 9:26. So what I'll do is in the next 15 minutes, I'm going to very quickly take you through the reference architectures and talk about some key operational challenges we have on the ground, right? So let's quickly jump. So the first problem, I really don't know what data I need. Okay, you're giving me. So please don't give me a sample data, right? My model cannot scale for your actual data if you just give me a sample data, right? Gone are those days when we said there are a million rows, take a sample of 3 months of data and run your model and then scale it up to the entire data, right? The data is becoming so important to us. I really don't want to do offline modeling, right? So if I'm a data analyst, data scientist, and I'm really good with R, Python, Julia, whatever we talk about, and then I do my modeling on the given data, and I come back to you, you will actually say, thank you, this is not what it is. You took the data which is a sample, but the actual data that is these insights are not helping me. So the challenge is offline modeling is no more working. So me knowing algorithms really well and preaching about how a Bayesian algorithm would work or a nearest neighbor algorithm would work is a passivity, right? So we've got to really understand what data do I really need, okay? And the moment I get to know, I also realize that this data is so discrete and disparate that I'll have to understand to see how to bring this data together, right? Let me take a very simple example in my domain, right? So I work for a financial service industry firm. We build products, and one of the use cases we work is settlements, trade settlements, right? So one of the projects that we were looking at doing was how do I measure the settlement risk? The settlements can fail at repositories for multiple reasons. Maybe because the data is partially given, or something went wrong, or incorrectly given because of multiple reasons. And if a settlement fails at a depository, what could be the potential impact on the business, right? So one of the important things which you can see in the diagram out there is when I speak about this data is not one set, right? I'm talking about the past behavior, which is more of a historic data. So how many trades have been settled in the last 7 years, okay, at a particular depository. That becomes historic data. And I know that's not a changing data, that's analytical data. I know on a daily basis my settlement data comes in, so I have to be really real time with it. I should be able to understand the new patterns that are coming in. Maybe settlements also failing because of the kind of operators who are sitting out there who are, submitting the tasks. You never know, right? And I also need to look at my reference data, which is like static data or reference data, which is like one-time data, which will not change too much. So from historic data to static data to transaction data, the data types really vary. So when such a thing happens, my challenge becomes bigger because the data is a combination of real-time to intraday to batch data. So if I build a model offline, it's no more of any value to me. I don't care. It just doesn't work for me, right? How do I address this? So offline model is not working, then the model is changing because new data is coming. So I thought applying a linear regression model with attributes for security type and let's say the demographics of the party would work very well for my model. But suddenly I realized that even the depository really matters, or the region where the transactions are being processed really matters. The moment the input attribute changes, a model is changing. If a model is changing, every damn thing on my machine learning project is changing, right? So it's not as simple as you learning R, being expert in running R Studio, taking in data in CSV format, dumping it out there, you know, using a library, running a model and saying, guys, I have an insight, right? It doesn't work anymore. The challenge definitely is an ETL, right? Extract, transform, load. The volumes are really becoming big, the data types are changing, and multiple things are happening. The second big challenge that I've encountered is with respect to, I didn't expect this data to be more this big. I've got one algorithm, let's say my decision tree algorithm, which I built on 1,000,000 rows today, and I give you insights using association rules or the rules which are derived from my random forest algorithm or something. But suddenly you want me to run this on your last 7,000,000 rows. I'm like, it doesn't work, right? Because it can't scale. My system is crashing. It can't do a lot of things in memory. I need to run this distributed, right? My model is really not scaling. So how often do I run this? So I can't run this offline and get you the insight and say, be happy with it. You will say, hey, I've got a data which has come just 1 hour ago, and my clients have done heavy transactions on it. Just put this out there. And I'm like, no, I can't support this format. No, I can't scale to 7 million. No, this is not the infrastructure I have. So if you look at it, one of the biggest problems in productionizing is what kind of technology stack do I use? What kind of architectures work in this context to get this running, right? I'll speak about that in a bit, right? And this is my favorite, right? I'm so excited. I'm so excited. I suddenly find an insight in some data that my client gives me. I go back and say, guys, you know what? All the transactions that you gave me, they're failing typically because, you know, there is an application, downstream application you're doing, which is not inputting data in the right way, or there's some users which are not waiting for the UI to respond and they're clicking continuously and trying to submit double entries to it, and your system is not working fine, so you know what, that's why it's failing, right? The client might come back to you and say, great, the insight is superb, but this is not adding business value to me. I'm losing some millions of dollars when I'm applying this. So can you really get to the crux and let me know on what you think is really valuable to me? So the domain knowledge becomes very important. So the subject matter experts, domain experts are really key to really working on a machine learning project. So you've got data analysts who don't have to really have domain expertise, but they need to understand the business enough to put the attributes together, but they really need to work hand in hand with the domain experts. Right, so very quickly, I'm going to cover solution part. So I'm going to give you guys exactly 15 minutes for questions. So I'm going to spend the next 12 to 15 minutes on the new age architectures, technology stacks, on how the complete landscape for machine learning is actually changing, right? So what I gave you in the last 3 slides that you see here, it's just the tip of an iceberg, right? So how do I really handle my problem? So, but when I learned machine learning, my professor didn't teach me how to do this, right? So do I also have to be an expert in Python, or do I have to keep myself abreast with the new upcoming tech stacks? How do I do that, right? So at least the book I published has got a lot of tech stacks. So what I'm going to do right now is very quickly spend a little time on the bottom of this mind map I have, right? So how is the mindset changing? How are people looking at solving problems differently, right? The first problem I spoke to you about is, you know, people are giving me data, or I'm getting the input data from different sources and different formats. How do I integrate my data was my first part. So data aggregation, or the ETL, is a very, very core strategy, and in the entire architecting of this machine learning, a significant time is spent. So in the entire project plan, if 20% of effort is given on data gathering and cleansing, today the projects are taking more than 70 to 85% of time in just data, because nowadays modeling is becoming easy, right? Because we've got tools out of box. I really don't know, I don't have to really understand how a k-nearest maybe algorithm should work. I just use a function which is out of box, and then all I've got to do is get my data right? So the data is becoming very important for us. So semantic data architectures are becoming key, right? So we're not really worried about the syntax of data. We're worried about the semantics of data, the meaning of data, right? So I've written an IEEE paper, a year ago, which I'm going to just very quickly run through in a minute, on how do we aggregate data. So you might be seeing the financial services data here, but this would apply to practically anything. So if you all guys have heard about semantic technologies, W3C, RDF, resource description format, ontologies, right? So I don't care what kind of data comes to me, in which format, right? All I've got to do is build a common vocabulary for myself and aggregate it to a common vocabulary. One example I give is one of my system calls, IBM, or let's say a repository called Bony as BNY, one system calls it BONY, one system calls it BMYN, right? So how do I call it commonly? And so many formats are coming, and semantically different structures are coming to me, right? I don't care about syntax anymore. I care about semantics, right? So if you look at it, this was a semantic conference. I was there where people are talking about how semantics will play a very big role in machine learning and data analytics and predictive analytics in the future, and how this will become key for aggregating data. So I don't care if it's a streaming data, I don't care if it's structured data, I don't care if it's coming from an RDBMS or a file. All I do is build my ETL strategy to do something called inferencing, right? And then I inference the data and build a common vocabulary and aggregate data on which I run my algorithms. Semantics not only, technologies not only help aggregating, they also help in building a machine understandable language. So when you have some formats like RDF, which I spoke about just now on ontology, it can be a simple log file. I take all the log files of a very huge application and annotate them in semantics and run my machine learning algorithms. And I say typically your application or your complex enterprise application is failing in the enterprise middleware tier. Your logs say your servers are going down at this time because the peak usage is happening out there. So semantics is really becoming very hot. So I would suggest you all guys watch out on the semantic tech stack. It's coming up, and there are a lot of articles coming on semantics for analytics. I can answer specific questions in the Q&A in case you have, right? So that is with respect to how do I bring data together, right? The second part is, the issue I spoke about, the real time and batch coming together. So I have got historic data, I've got static data, I've got the real-time transaction data coming to me. And my models have to work on all the three at the same time. So how do I ensure my model scales for a real-time data need as well as a batch data need, right? That's where the new architectural patterns called Lambda architectures and Kappa architectures have come into light, right? So today you speak about Apache Spark, you talk about Kafka. So all these tech stacks, open source tech stacks which have come, really help you to run your models both real-time and batch together. So conceptually, when machine learning came, people said, give me data, give me a sample, I'll run it, here's your model, here's your insight. Now people are saying, I don't want historic data. Don't give me descriptive analytics. Give me prescriptive or predictive analytics, right? So where I can be forward-looking and I can solve my problems, proactively, right? So these two architectures help processing real-time and batch at the same speed and efficiently. So I'll give you examples of the tech stack out there. The next important thing is polyglot persistence. So some of you guys must have heard about it. So these in semantic data architectures I spoke about the need where we've got multiple data sources coming in and the formats are different, and for me to identify the unlabeled streams, get a photograph and identify if there's similar photographs or get some data and try to understand and attach meaning to it. I can use semantics. That's one way of doing it. The other way is I would say I don't care about it. I really don't want to aggregate this. Okay, I've got an RDB in a store. I've got an Excel format coming in, CSV format. I've got data warehouse which is giving me historic data. I've got something like a Hadoop file system which is giving me unstructured data. I've got some NoSQLs, XML stores, graph stores, which is giving. I would like to run a query across all the stores together, right? So that's where the polyglot persistence is coming into picture. I really don't want to care about aggregating or virtualizing my data. I want to really worry about having them in their place, that is querying and running my model across. So how do I do that, right? So polyglot persistence is becoming very important, and there are a lot of data stores which is supporting these. So one example I can give for this is Green Plum. Green Plum does support a polymorphic data store. So you can have a column store, you can have a row store, and you can merge them and query them together, right? Or one of the things which I'm working on in the data fabric solution for my firm has got an in-memory store, fast data. It's got NoSQL store for historic data. It's got an RDBMS for the transaction data. And I have these three databases synchronizing with each other, and then my machine learning algorithms to work on them together, right? So that's what it's about, multi-model data architectures, right? It's become pretty hot. It's been there even before we all guys were born, but it's coming more into picture now because of the kind of new age problems and use cases that are evolving, right? The last but not the least, right, I would like to cover about the shared nothing data architectures. So we are speaking about scale. So the first slide I spoke about operationalization was primarily about, the typical RDBMS is working. So you guys must have heard about vertical scale versus horizontal scale. For example, at some point in time, you can't add hardware anymore. You have got to really spend millions of your money on that. So share everything to share nothing data architecture. So typically your RDBMS solutions are shared everything. The massively parallel processing databases which work on clustered nodes, right? They are the heart of the new age tech stacks which are coming in. So I really don't care how much of volume I'm processing. I've got my model which gets distributed on the network and runs on the data and aggregates the result and gives me back, right? So typically we are talking about something like this, the shared nothing data architecture, where your data and processing is all happening, siloed in different nodes, and then it's going to operate separately on that, right? This is about the complete new age data structure. So we've got NoSQL data stores which help us, scale to formats which are not foreseen or which are unpredictable, right? So multiple of these happen. So what I want to show next, very quickly in the next 1 to 2 minutes, okay, is one of the things which I've done as a very key work in my project is try to build these algorithms to scale. So what are you seeing out here on my screen in terms of the list of all these algorithms? Some of these algorithms don't work in a parallel mode. So what I did, I took 5 tech stacks. I took R, which most of the machine learning students and practitioners like, right? I took Python, and even Python is most adapted because it really scales. And then I took Julia, which is really hot and upcoming, and it's based on a C++ base system, and it really scales very, very well. And I took Lambda architectures like Spark and something like Mahout, which works on large-scale systems like Hadoop. The entire list of algorithms you all are seeing out here, I have built it, and my GitHub is available for public access. Okay, so you could just search with Sunila Gollapudi, and you would find my entire code out here. So you can actually go to specific Spark or Python mount. But by the way, Python, I've not used any native Python out here. I've used scikit-learn libraries. So let me just give you a simple example of artificial neural network algorithm which I built that you could see on the Python. Right, all the libraries is all executed code, and you guys could download and try working this out. What I've done is try to make these work on a platform like Hadoop. Right? How do I integrate Scikit with Hadoop? How do I integrate Julia to work on Hadoop? How does Mahout work with Hadoop, without Hadoop? And I'm taking all these tech stack names because they're all open source and we all can freely try them out, right? So I would suggest you guys to access this, right? My name you could very easily find with Sunila Gollapudi. Let me just drag this. So this is what my profile is as, Sunila Gollapudi, and you all can find it there. And there are more than 200 pieces of code that you can find in all the learning algorithms I mentioned out there, right? In Spark, I've integrated Java, Scala, as well as Python code out there, right? So this is very importantly that you can see the entire source code is available here. You can see it and use it. And by the way, you all can contribute to improvising these algorithms as well. You can feel free to contribute it. So just before I end, 30 more seconds from my side. What I've seen as a practical problem in machine learning implementations is ensemble methods. I spoke about learning methods a while ago, right? These ensemble methods that you see out here on my screen, right? This is nothing but a concatenation of multiple models. So every time I solved a real world problem, I had to use a combination of models. It never happened that I used one model, it worked, right, in my experience. It was always ensemble. The second is the problem I perceived was a problem versus what I solved was another big thing which I had to really keep my antennas up and open for, right? The third important thing is the data cleansing, arbitration has become very, 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 very key essential part. And 65 to 75% of efforts have been going out there, right? So this is all I have for the session today. I've taken 3 minutes more. I've grabbed your question time, but I now open this up for the Q&A. And we could do this. Let me just get my slide out here. Sorry about that. Right. So my Q&A opens up here, and looking forward to hands raising up. Yes, Ajay? So I can see Ajay Unagar. Yes. Yes, Ajay. Reinforcement. Okay. By the way, very good question. So let me just spend a minute on what reinforcement learning is, right? So, okay, what are the best architectures for data streams? Okay. So let me go down. So I've seen the question on reinforcement learning. Let me just very quickly address that. So reinforcement learning is pretty native to humans. Okay, the way we teach our children, for example, kind of a baiting. Um, Baiting kind of thing. So for example, every time I run a model, all the positive, okay, what I do is I'll very quickly take you through the reinforcement learning's idea. So can you see my screen out here, which contains the scope of reinforcement learning? So typically what we do out here, I've given some, use cases out here and where this is used, right? Depending on the response, right? Whatever the reward comes out, we give it as an input back to the algorithm, right? For example, we are teaching a dog or training a dog. So the moment we train a dog, we give, kind of a bait to the dog and say, good job kind of thing, right? So it reinforces and the learning is fed back and it's given. And some of the neural network algorithms also will be using this, right? So the entire direct learning, the policy-based learning, all will be covered in this. So some of the algorithms are Q learning, TD, temporal difference learning, all these will be covered. You would see some of the business case I'm covering out there too. You can just look at these. I hope I answered your question. Let me just see. So is a neural network helpful? Absolutely. So machine learning is a branch of artificial intelligence. The difference between machine learning and artificial intelligence is machine learning techniques are used for artificial intelligence problem solving, right? So artificial intelligence is more focused on solving human-like behavior, or wherever we need human being-like behavior or the way the brain works, that's where artificial intelligence comes. And most of the algorithms we use for artificial intelligence are machine learning algorithms which are deployed. But they're very much complex because the multiple data points, the linking, feed forwards, the backward propagation, all that happens with multiple data points out there. So let me see if I have any further question. So in which scenario is reinforcement using? I covered that. Neural network is helpful, I covered that. In case both implement, is there any particular platform? Okay. So typically there are many options. So I covered a lot of architectural aspects with you, right? When you say platform, I'm assuming it is a technology choice you're talking about, right? What tech stack do I use, right? One thing I would ask all of you guys to keep your antennas up and open is to get yourself skilled up with Python, right? So Python is one of the key tech stacks we have, irrespective of how many tech stacks come in the market. This is going to be hot, right? And scalable too, right? So when it comes to platform, it's again very specific domain problem I'm solving. So the example that I've given you, I went for something like a NoSQL store, like a MongoDB, right? And I've got examples where I used Hadoop with Spark, a combination of these two, right? And I've used Python as one of the implementation algorithms which have run on Spark and on Hadoop to scale. So Spark for real time, Python for scale, and Hadoop is for distributed processing. So in terms of choices, we have quite a lot of choices. Open sources, I took some examples out here. But technically, let me see if I've got some libraries that I can show you. Just give me a minute. So the tech stack wise, I'm not sure. Patterns. I was hopeful about finding this. I'm sorry about this, but I typically have got this tech stack available, right? I could just share with you. So Java-based tech stacks we have. Then we've got Python-based tech stacks. Scikit-learn is one of them. Then we've got mlib with Spark. So all these tech stacks are available. I hope I've answered your question. Yes, so it looks like I did cover the questions. Okay, is there any algorithm which can blend based on scenario of the data given to it? Okay, by the way, every machine learning algorithm is expected to blend with scenario. So it's not about one algorithm which blends. So when I gave you an introduction of machine learning where I was talking about building intelligence into a machine to be able to learn from its own experience, right? It takes data as the base and blends. So I don't code for a new attribute coming in. So every algorithm we're speaking about is expected to blend with the scenario. And let's assume the kind of model I choose. So let's take an example, okay? This is a good question. Let's take an example. Let's assume I'm talking about buying patterns of a customer, right? So initially when I built my model, I took the customer data, I took the demographics, I took the gender as 3 key attributes to check if this customer will buy this particular product or not, right? But suddenly I realized I built a model, but suddenly I realized that when I tested on my real-time data, it's not giving me the correct accuracy. I realized there are more attributes to be added to it. So the moment I add 2 more attributes, let's say it could be, if you're married or not, if you have children or not, right? If these 2 attributes also make a difference to the buying pattern of you, my model has to take these 2 attributes into and blend it into the model and give my results based on that, right? So it's expected to blend. Mind maps. Yes, I can share the mind maps, of course. And what I'm going to do is these mind maps, I'm going to put them on the GitHub, right? The link which I've given. So let me just reiterate. So GitHub is open for everybody. All you've got to do is do GitHub. So on one of my slides, I've given this. So on my first slide, intro slide, in fact, all you could do is that. So if you look at it, github.com/Gollapudi, you find it. So I'll add the images and mind maps for sure. I'm currently working. Hello, ma'am. This is from Mr. Patil. Hello, ma'am. I'm working over one project in which I combine 2 big data techniques, Hadoop and Spark for storing, right? Analyzing the web serving log. But I'm a bit confused. I'm sorry, but I'm a bit confused that which learning is best suitable for analyzing log files, supervised, unsupervised. Very interesting question. So when we're talking about supervised, unsupervised, it's predominantly dependent on Mr. Patil, it's dependent on rather Roshan, right? It's dependent on the kind of attributes you have. So on the log files, in my experience, I've done a very huge project using semantic tech stacks, and I've used Spark. So semantic tech stacks annotate. So in case of log, typically you can go with a key value pair, right? So you say, the log generated by this user ID. User ID is equal to Roshan, and the transaction ID is equal to ABCD. So how do I do it? So your supervised, unsupervised question, in my opinion, is not relevant in this context because it depends on what you want to derive from it, right? Let's assume you are analyzing your logs to identify system behavior or responsiveness. So how fast is my application responding? If a user clicks on a button, what's the response time? So I exactly know what the problem is. Then it becomes a supervised problem, learning problem. If I don't know what I am trying to understand, just taking the patterns, and depending on the kind of error logs that they come there, I say, your system went down consistently every Friday at this time, right? So I don't know what I'm looking for, but I'm searching. That's where the supervised and unsupervised learning comes. So talking about Hadoop and Spark, right? So Hadoop typically is a file system. So if you have got a log which comes in, I can blindly dump all my logs, take all the key value pairs. So it's very important you follow the logging standards, right, Roshan? Rohan, I'm not sure if I got your name right, but your key value pairs have to be really annotated well, and I could query based on these. And Spark typically helps me to, help get the streaming data. So my log files are generated every other minute. I take it down every 5 minutes, 1 minute, 3 minutes. I can stream it using streaming libraries of Spark and apply my machine learning algorithm. So Spark typically we don't talk about it as a storage medium. If you have Hadoop as a basis, that can act unless you really want to have Spark key value pair to be annotating it. But typically you can use them in combination. I hope I have answered your questions. So let me go to the next one. I'm a second-year student and new to machine learning. So I just want to know how do I structure my study? I don't get lost in this week. Okay. How do I proceed after this in the field of data mining? So saying it's really, really vast. You're right. Are there any courses? You're right. Yeah. So basically, if you're a student and you're looking at this field, it typically depends on how do you want to position your career. If you're a domain expert, your focus could be on learning some basic R, understanding how algorithms work, how the patterns can be understood, but focusing on domain problems. So you become more of an SME out there. But if you're a data analyst, you've got to really understand inside out of tech stacks. So all the new architectures I spoke about just now, be it Lambda, Kappa, be it Semantic architectures, you would be a primary consumer of that. So you would be working on platform choices, which would scale, which will not scale. Do I go with Hadoop? Do I go with NoSQL? So typically that's different for you. So you cannot be all for sure. So you've got to choose on where you want to build your specialization in. So at the end of the day, any data science project or machine learning project you're working, you'll work as a team. The team would comprise of data engineers, data analysts. Data engineers focus on massive parallel processing, database choices, polyglot persistences. Data analysts really focus on algorithms, the choice of frameworks to use in machine learning, and the subject matter experts, domain experts, focus really on, what's the domain problem what you're looking at solving. So all of you, all these people need to have the basic knowledge, but you're always working in conjunction, but there's no one person who can solve this. So you've got to make a choice between that. But online courses will teach you the first 15-20 minutes of my lecture today, completely. Anything else? Advanced. Any questions? How do I expand this? Yes. Let me go through all the questions and see if I've missed any. What's the probability of a lead to turn into a paying customer? Oh, wow. I really like this question. To be honest, okay, machine learning has been a field, right? So where, like one of the things that I told you is you would want to add value to your products and build some intelligence and give it back to them. Typically what happens is the intelligence you're trying to look at building in the system might require you to take care of some security issues on whether you're merging 2-3 clients' behaviors and giving. So in my opinion, it's not going to be very easy. Turning into a paying customer is not very easy because on an ongoing basis, you give a one-side insight into the application, insight into the prediction. You're not sure about the accuracy continuing, and you've got to work on the same use case back and forth. So this is a definitely difficult problem unless you've got strong domain experts working with you and positioning the responses back to them. So we definitely are facing a lot of problems to convert our clients to pay in our domain definitely. That's because our domain has got a lot of regulatory concerns also, security concerns, where we're able to not able to do it well. For example, things like assessing election patterns and all, you could generate, put up there, and central government, those things are not very difficult, but doing key domain projects and converting those clients is definitely not an easy thing unless you have a strong domain expertise and show the value. So for them, the clients will always be, so what does it mean in terms of dollar costs, right? So it's how can we model sequence of actions in machine learning? So this is not a difficult thing. So I very briefly touched upon something called ensemble learning, right? So if you look at it, ensemble learning is all about using multiple models parallelly or sequentially to run this. I'll take an example with the log file example that one of you guys quoted out here. So typically log files are really streaming data, right? So we look at that data and try to identify what are key attributes for me that I have to consider, right? So I run something like a k-means clustering algorithm to categorize my data, and the output of the data I probably use on a random forest or on a specific algorithm like Bayesian learning, Bayes algorithm or something like that, right? So typically, I have not seen any real-world example which worked on one model. So with the new tech stacks coming up, they all are like basic functions. So you do one based on the output, you label your data, and the label data is given as another model. It's pretty easy to code, be it Spark or any tech stacks you take. It's not that difficult. In terms of other tech stacks, we've got a lot of workflow tools coming up. One of the tools that we talk about is Uzi and Hadoop, where you could configure your MapReduce, machine learning jobs, and then schedule them to run in a specific order, right? So that's also happening in a lot of cases. Sequence, right? Next, software engineer, C++. Okay, how can a software engineer with 5 years of experience in C++ and Java dive into machine learning? So machine learning has got two parts, right? So I typically would consider you falling in the category of data engineer or data analyst, right? So if you're into coding and you understand how to do this, I would categorize you there. So a basic overview of what are all the learning methods which I showed you in my mind map out here, the bigger picture out here, right? Understanding these, how each work, where to apply what problem, and what kind of domain problems solve these, and then focus on some top tech stacks, right? So if you are a C++ and Java guy, something like a Mahout or a Spark would fit in very well with you. You can upgrade yourself into Scala as well, right? Learn those tech stacks, and you could become one of the data analysts who writes or who does the modeling, right? And runs them on huge platforms. So domain need not be a key learning for you. You might work in conjunction with domain expert, is what I think. Abhishek. Being a student, hard to understand, I think I answered Ajay. Then is there a rule, any rule of thumb when deciding which architecture Lambda to adapt for? Of course. So the topics that I spoke about, right? So basically, in my opinion, one of the latest use cases which have come up are talking about batch data. So Lambda typically has come up and it's really doing well. It's able to scale because it's allowing the access to streaming data in real time. So it's not like I take a snapshot of a static data and run my R on it, right? It's not that. So if you see the new tech stacks like Evolution, all these guys are coming up with supporting, running R in real time as well, right? But if you look at it, frameworks like Spark are by default for real time. So a typical business case which you follow is the real time access, right? Overlaps, yes, there are overlaps in these architecture. So I might have two problems with me. I might have two different data sources with different data structures coming in, and I might have to, you know, I might have to use Lambda architecture to work in multiple formats and run on polygraph persistence mode, which I'm currently exploring as well. So there are overlaps, but nothing is isolated. This is a brilliant question. I really love this question from Akash Tendon. It's very good. So you will end up, getting more questions. So what I would suggest is I am reachable on sunila.gollapudi@gmail.com, right? And you can reach out to me for any further questions. So let me see the any other questions. There are quite a few questions. I'm pretty impressed. This is great. Speak here to the mic. Okay, I'm sorry about that, Animesh Verma. I'm seeing this late. What does your book focus on? My book focuses, I've got two books. The second book is Practical Machine Learning. It focuses on all the learning algorithms that you're seeing on my screen out there, and all tech stacks like Julia, Python, Mouse, Spark, code I've written from scratch and showed them how to execute on Hadoop. That's what it focuses on. So it's called Practical Machine Learning by PACT. My name is Ankit. I want to work over AI-based personal assistants and analytics. What should I do and where should I start? Okay, artificial intelligence, deep learning, machine learning is a subset of that. So you will have to start with learning the core machine learning algorithms, which I am again showing you out there. You have to understand the categorization, and you have to at least get your hands on two tech stacks, right? I would say R for simple things, right, doing the day-to-day things, but something like Python or Julia or Spark, one of them, you pick them up, preferably Python, to get hands-on to implement these and learning those libraries. So please feel free to look at my GitHub and take the code, shout me, scold me, something is not working, please feel free and give the feedback to me on that, right? So it's publicly available. I made it publicly available. Typically that would have come to you if you bought my book, but that's right now I've made it. Best architecture for data streams, Lambda architectures. Currently Spark is working very, very, very well for us. It used to be Storm earlier. So Aryan Singh, oh, he's left. Okay, but anyway, I think it helps you guys. So it's Storm used to be on earlier, but now it's Spark, which is working very well. The streaming APIs which are available, which works really, really well with that. So I've got some real-time business case implemented. So Ashish Dwivedi, I'm CSE graduate. I've done project implementation using MATLAB. I have basic query regarding the mathematical knowledge required. You guys have to be basically analytically strong. You don't have to be math expert or statistics expert, because most of the frameworks that are coming up now have got out-of-box functions, right? You don't have to really understand how a CART algorithm works or how an a priori algorithm works or how support vector machines works. If you understand syntax, give the inputs and try to get the outputs, you're there, right? So don't worry about your expertise. You can remain as good as me. So you can do that, no worries at all. How do I start off as a beginner in ML? I think I answered this. Python is very important, province I, right? You've got to get the basics and understand algorithms, that's mandatory. The flow which I've given in the middle is important. How clustering is useful in learning? Clustering is a mandate for every business case I've solved, Gaurav, right? Without, for example, I told myself I knew data, but all the time I had to run clustering algorithms to really categorize my data, convert my unlabeled data into labeled data. So clustering is a mandatory step, in my opinion. K-means clustering, if you know, you are really good to start. Quite a lot of questions. How are we doing on time? Okay, so we have 15 minutes. Let me try covering most of these questions. You can feel free to reach out to me if I miss any questions. I'm really sorry about that, but you can feel free to reach out to me. How to upgrade rules-based systems to machine learning? So there is Harshal Raj. you cannot upgrade a rules-based system to machine learning, right? You've got to build it from scratch. So a rules-based system is hand-coded by you, right? Machine learning is not hand-coded by you. Machine learning learns from data. So the first step I started is whenever you write rules like BPMN or a workflow system, right? You're actually coding for if the input is AI, do this. If that's BI, do this, right? So we're not expecting machine learning systems to be hand-coded. We're expecting them to learn from the data. So you cannot call this upgrade. Okay, you're going to build a machine learning algorithm. So if you already have a rules-based system, you probably have a great start because you already know typically what kind of rules would come in and what attributes would matter. You starting your machine learning project to start from scratch with algorithms is great, but I would not recommend using the word upgrade there because typically it's not an upgrade. You scrap your rules engine and get your ML system out there. And can one beginner computer student become ML professional? Why not? Anybody can become. In my knowledge, like any other tech stack, Himanshu, what you learn in the classroom is very different from what you implement on the ground. So you might just get in a job, but you will not have any. You not have any. Knowledge that you earn out of or learn out of what you learn in the class. You will understand how a model works, but for what business use case, what you apply, that is typically what teaches you on the ground. So there are a lot of people have got a problem with the voice. Hopefully it's not everybody. I'm sorry about that. So why use Mahout? Okay, Mahout is actually a machine learning framework for Hadoop. Okay, so machine learning framework for Mahout, it works on Hadoop very, very well. It can work without Hadoop too. It's got its own libraries which are Java based. So if you already have Hadoop system, you can use Mahout too. But unfortunately, even the latest version of Mahout, which is 9.x, does not have all the algorithms. But still, if you look at my JIT, I've given a lot of Mahout code out here, right? The HTML5 user. I don't know your name, but the Mahout code, there's a lot of code I have given which I've handwritten for algorithms that are not available. So please have a look at that, right? Is Theon good or Skykit? Very good question again. By the way, I don't think you're comparing apples to apples when you say Theon and Skykit. Okay, so Chandrasekhar, he left the room, but Theon typically specializes in deep learning libraries using Python. Okay, so Theon, at least today, is not going beyond deep learning algorithms, right? Skykit is not restricted to deep learning. It covers a lot of other algorithms too. So you're not comparing apples to apples here. So Theon is definitely upcoming, and I don't know of any systems which are in production with Theon. I might be in dark, but Kapil is not getting any audio. I'm sorry about that, Kapil. Which language from Python, R, Spark, X you mentioned would be most covered for ML in your future? I would say Python, and please watch out. By the way, Spark can run on Python and Java. Okay, so if you know Python, you're pretty much good with a lot of things. R, if you're a domain expert, I would suggest you go for R. Don't touch Python. R would help you run some simple algorithms and very simple to use with the studio and libraries. You could do that. So Spark definitely in conjunction with Python, I would say. Please watch out for Julia as well. I've got my code here for Julia. Please watch out for Julia. Julia is really upcoming and it scales very, very well. It didn't have too many libraries. I have written a lot of code handwritten out here myself. So please have a look at this Julia code. It's a scripting language. You could see this here. Okay. What are the data after processing gets corrupt? Will it change the model? After processing gets corrupt. So it will not change the model, Manan. Typically your model results or prediction will be the accuracy percentage will go down. The data is corrupt. So you'll have to go back to arbitrate your data. So it will not corrupt. It will not change the model. The model will still work with input corrupt data. So it could be a noise data or whatever. But it will not give you the prediction with accuracy. That's what it means. What big data is used? What is the final question? The model answers. I'm so sorry, Mohammed Zaman. I have to understand your question. What is the final question the model answers? That's your business problem is what my assumption is. Right, huge data, find check whether the model or algorithm is working and what the prediction is going. So that's your domain problem, Mohammed. So if you're clear about that, that's what you will model, build your model to solve for. That's your domain model. Okay, so some people do have a problem with the voice. I'm so sorry about that. Good books for machine learning? Okay, let me be good to you, my book. I'm joking, but there are a lot of books on machine learning. I would really suggest you guys go for Coursera too. It's a good course. A lot of new courses coming up. I'll try to post some links on my chat for you. Or please drop me a mail and I can share some links with you. How much of mathematical rigor? I answered this. Nawazish Khan, not too much. All you've got to know is the libraries and you should be fine with it. No statistics too. By the way, I'm not an expert in statistics. So it works. Yes, of course, deep learning is picking up very, very well. Could you share the picture diagrams? Of course, I can share. Complete deep learning picture, I can share. So I think I have got a full-fledged deep learning picture with me here. Yes, of course. So I'll share this with you. All right, done. So I'll put in the GitHub, so I'll take it from there. Coding skills, Python C++, okay, is essential. Basically, Python, if you do, you're going to be doing well. If you're going to be a data analyst, Python, I would suggest please focus on that, and Julia. If you're Java already, great. So you can work with Spark very well on that. Time series data, so, okay. Pradeep Bansal, I love time series. Okay, so, but the thing is, the models are not tied to the data types. Time series data is a data which comes as a flow to you. All the models work on time series data. It's the data structure you would like to choose to store, right? So with respect to the question, all models would work well with time series, but you should have a very good distributed data architecture underlying, be it Hadoop or NoSQL or MPP to get it up and running. Make learning model healthy related to, yeah, it's very related to this. Could you answer this? Asked about, yes. What, Pradeep, what ML algorithm need to be well versed with to build chatbot? So, typically association rules. The chatbot is considered more of a supervised learning. Association rules and clustering would really help very well out there with decision trees. Can you explain? Okay, in the chatbot, the attributes are many, so combination of linear regression and decision trees would work very, very well for you. Prathamesh Rudrekshwar, he left, so I'll not answer this for now. I'm sorry about that. I think I'll answer people in the room. Pratik Tiwari, is there a way to debug existing related machine learning algorithms to optimize them? So by default, okay, your debugging is done by your training data, right? Pratik, when you have got your training data which is given, and the data feeds into your stuff, the output and the accuracy of your model tells you if the model is working fine or not, right? If the accuracy comes down, you have to go back and look at your data. Either your data is corrupt, like somebody said earlier, or you are doing too much of overfitting on the data. So you've got to verify that. Sentimental answer for absolutely, completely. It does fall under unsupervised learning. So more than, okay, let me correct myself. I'm sorry about this. So sentiment analysis is more of a text mining problem for me, right? Depending on the kind of words you use in your comments on a web application, you would really get answers to this. I mean, you take some keywords and text mining is more. So it's neither supervised or unsupervised. It can be supervised, it can be unsupervised. So if I know the business problem, like what kind of sentiment am I trying to assess, that becomes a supervised problem. If it is, I don't know what the outcome is, it becomes unsupervised. But typically categorization of algorithm, it's text mining, text analytics that would come in. Yes, what else we have? What algorithms would be efficient when users? Good evening, so they repeated. Okay, Pujit, thank you. I thought I missed too many questions. Sentiment. Yes. Wow, Pujit, you asked the same question a lot of times. Okay, I'm just going down. Yes. So I think I've answered pretty much. I will give 2 minutes time in case you think I've missed any questions. I'm really thrilled to see the participation in the group. I'm really privileged to be here in this room to be able to answer. TensorFlow, wow. So Shivam, depending on the TensorFlow and Theon, I will answer a lot of questions for you. Would you mind reaching out to me on my email ID? I can get you some time. I can spend some time and we can ask. I can really get you the answers. So Shivam, I've answered some of your questions. Here we can start. I would suggest you can go for some courses on Coursera. They're really good to start with. And if you go to YouTube, you can start looking at more videos. So I'm myself starting a machine learning video channel that you all guys can subscribe to. So I'll let you know when that's out. Maybe in a couple of weeks from now. How likely are ETL developers with knowledge of SQL, Python, with theoretical knowledge of ML can get a job in machine learning AI fields? So you guys would typically be data engineers for me. There's a lot of demand for you guys. Definitely you can get there. So you should be solving all the points I mentioned. You should be able to do data aggregation. You should be able to do parallel processing. You should be able to do polyglot persistent solutions. I told you 65-75% of the work is out there. Reinforcement learning wasn't, so reinforcement learning I covered a bit, wasn't. I'm sorry if I missed again. Vikash Verma, he's neural networks, right? So I think we have reached to the end of this MATLAB. Will this be in career orientation? So learning a specific tech stack is fine. I mean, that's not a bad way of starting. You understanding what deep learning is all about, how neural networks work, how the back propagation works, you understand that. And take one tech stack, learn, definitely is a good start. But try to get your hands on some of the open sources too, right? That will be definitely adding a lot of value to your resume. That's what I suggest. So I think I pretty much went through. I'll give you guys 1 more minute. If you really have something important, drop a note there. But like I said, I'm definitely accessible to all of you, and you can reach out to me on sunila.gollapudi@gmail.com, and you can please check out my GitHub. Mind maps I'm going to share with you on GitHub. I'll put a separate folder and you guys can access. What else? So I think that's what it is. Thank you very much. Thank you, Hackerearth, for this opportunity, and thank you to such an overwhelming and excited group I have today. It's been really nice to be talking to you guys, and like I said, you can always reach out to me. Thank you so much, and all the best to all of you.